Today, we're going to explore one of the most famous and brilliant logic puzzles ever created. It's called the Prisoner Hat Riddle. It's a test of reasoning, teamwork, and mathematical thinking. At first, it seems impossible. But by the end of this video, you'll not only understand it, you'll be able to explain it to others too. Let's begin. Imagine a prison. It's not just any prison. It's a place where a very unusual challenge is about to take place. There are 100 prisoners. They are brought into a large hall and made to stand in a single file line. Each prisoner is facing forward. That means every prisoner can see the hats of the people in front of them, but they can't see their own hat. And they can't see the hats behind them. Then, a guard appears with a box. Inside the box are 100 hats, some red, some blue. No one knows how many of each. The guard places one hat on each prisoner's head. Here comes the twist. Starting from a prisoner at the back of the line, the one who can see everyone else's hats, each prisoner must say one word only, either red or blue. That word is their guess of the color of their own hat. If they guess correctly, they live. If they guess wrong, they die. The only communication allowed during the process is that single word spoken aloud. No other sounds, no signals, no tricks. Now, the prisoners aren't completely doomed. Before the hats are placed on their heads, they are allowed to talk to each other. They have as much time as they need to come up with a strategy. But once the game starts, they're on their own. So here's the puzzle. What strategy should they use to save as many lives as possible? It may sound like a guessing game, but it isn't. With a clever plan, the prisoners can save at least 99 out of 100, and possibly all 100, depending on luck. Let's break down how. Let's pause and think. The last prisoner in line, prisoner 100, can see 99 hats in front of them. That's a lot of information. They can't see their own hat, but they can choose to use their one word wisely, not just to guess their own hat color, but to send a message. That's the key to the whole puzzle. What if prisoner 100 uses their word to tell the others something about the overall pattern of hats? That's exactly what they do. Here's the plan the prisoners agree on. Prisoner 100, the one at the back, will not try to save themselves. Instead, they'll send a signal. They will count the number of red hats they see in front of them. If the number of red hats is even, they will say red. If it's odd, they will say blue. That's it. That one word, red or blue, now becomes a code that tells prisoner 99 what they need to know. Let's walk through how. Let's say prisoner 100 sees 44 red hats. That's an even number, so they say red. Now prisoner 99 steps up. Prisoner 99 hears red and knows the number of red hats ahead of me must be even. So prisoner 99 looks forward and counts the red hats. Let's say they count 43 red hats. Oh, that's odd. But the first prisoner said the total was even. That can only mean one thing. Prisoner 99's hat must be red to bring the total count to 44. So they say red. Correct. They live. Now, prisoner 98 steps up. They heard the first two guesses. Red from 100, red from 99. They know what those words mean. They also count the red hats ahead. They use that information to figure out their own hat color. At each step, the prisoners update the red hat count in their heads. They compare what they see in front with what they've heard before. Each time, they can figure out their own hat color. This process continues, all the way down the line. So why does this work? It comes down to something called parity. Parity is the idea of whether a number is even or odd. By fixing a known starting point, prisoner 100's observation, the rest of the prisoners can compare what they see with what they heard. They adjust for each guess and can keep track of the changing parity of red hats as people confirm their own hat color. It's like passing along a running total, updated at each step. This logic guarantees that 99 prisoners can guess their hats with 100% certainty. Only the first prisoner, number 100, is guessing their own hat. They don't get any information about what's behind them because there's nothing behind them, but every other prisoner benefits from the signal they send. So far, we've used just two hat colors, red and blue. But What if there were 3 or 10? Could the same idea work? The answer is yes, but it gets more complicated. The prisoners would need to agree on a system of modular arithmetic. That's math involving remainders. For example, if there are 3 colors, they could assign numbers. Red equals 0, blue equals 1, green equals 2. Then they could use the sum of the color values in front of them, modulo 3.prisoner 100, could use their word to indicate the modulo sum, and the rest could decode it. It's still possible to save 99 prisoners. The method is just more complex. This riddle has many versions. Some limit the number of colors. Others make the line circular. Some allow the prisoners to hear past guesses. Others don't. Some even let prisoners see behind them, but not in front. Each variation requires a different strategy, but the core idea remains. Use limited information cleverly. Use every allowed word as a tool, not just a guess. This puzzle isn't just a brain teaser. It teaches powerful lessons. It shows how a small amount of communication, just one word, can carry deep meaning if encoded cleverly. It demonstrates how cooperation and logic can overcome seemingly impossible odds. And it's a perfect introduction to real-world concepts like binary communication, parity checking in computers, error correction, team decision-making under constraint. It's fun, it's clever, and it's deeply mathematical. The Prisoner Hat Riddle is more than just a test IQ. It's a demonstration of strategic thinking. The prisoners aren't relying on luck. They're not guessing randomly. They're building a system, a method, a plan, and that's the real lesson. With a little logic and teamwork, even the most hopeless-seeming situations can be solved. The cleverest word is sometimes the simplest. So now you know, a deadly puzzle, solved with logic, one word at a time. It wasn't luck. It wasn't magic. It was planning, reason, strategy. The Prisoner Hat Riddle reminds us that even in silence, even with limited choices, a smart system can save lives. It's not just about hats. It's about how we use the tools we're given, how we communicate, how we think under pressure. Next time you face a challenge that seems impossible, remember this story. Remember the 100 prisoners. And remember what one word, used wisely, can do.